Okay, everybody, today we're going to have a little lesson on how to graph polynomials for 3. Graph polynomials without a calculator, given some information. Okay, first thing that's important for us to know, remember, realize, is that the power or your highest degree of your polynomial is what's going to dictate the end behavior of your graph. So what did Mrs. Malik just say? Okay, so x squared tells us something about a graph. We know we have a parabola. X to the 4th also gives us a graph with a parabola shape. A little bit wider maybe, but same concept. What's important for you to realize is if you have an even exponent, you will end on both sides with your arrows pointing in the same direction. Keep in mind also though, if your leading coefficient is negative, your degree is even, your graph flips and your arrows may end going down. Same with the negative x to the 4th, upside down wider graph. But again, what we're looking at is the end behavior. So if somebody gave me an equation and there was an x squared in it, and that was my highest exponent, that was the degree of my poly, I would know exactly what that graph is going to look like. Okay, dealing with odd exponents and x to the 3rd. Odd exponents leaves you with one end pointing up and the other end pointing down. Same if we make it negative. Well, negative x to the 3rd is going to flip your graph, and we'll have one end up and one end down. X to the 5th will be a little bit different, but if you're only talking about end behavior, you are following the same sort of pattern. Quick sketch and a quick x to the 5th minus x to the 5th. Okay, so basically, moral of the story, any even degree will end with both ends up or both ends down. Any odd degree will end one up and one down. Okay, so that may make sketching these a whole lot easier. Important to remember too that polynomials are continuous. These graphs won't have any interruptions. They won't have an asymptote. They won't have a hole in them. Terminology that we need to get familiar with. Extrema. Extrema is just that. It tells us the extremes of our graph. Now, up here, the extremes of our graphs are our mins and our maxes, and that's exactly what we're talking about. Maxes, mins, high points, low points. If someone told me what my high point is, I know how to graph this, and I know I have a turning point right there. So high points, low points. Another word for it is turning points. Okay, well that's easy. Let's look at a couple graphs. Graph number 1, graph number 2 is a little bigger, and graph number 3. Okay, graph number 1, come up, go down, come up. I see one min, I see one max. So in this case, I have an extrema of 2. My second graph, let's come up, let's go down, let's come up, let's come down. Let's see, I see 2 high points, a low point. So I have 3 extrema. I guess I could put some colons in there. Then my last graph, kind of boring, old school. 1 extrema, basic parabola. Now I can tell just by looking at this probably what the degree of each of these graphs is. This one looks like a typical x to the 3rd. It turns out there's a pattern. This one looks like it could be, well, definitely it's an x to an even power. And the little trick you're going to have to remember is it's always your extrema plus 1. So in this one, the degree is going to equal 3 plus 1, or 4. It'll be obviously negative x to the fourth somehow, but that gives me a lot of information. And then the next one, simple basic parabola, you guys know, is x squared. So again, the degree would be 1 plus 1, which would be 2. Because the rule is you're always going to add plus 1. Here your degree was 3 because it's your extrema plus 1. Easy to remember. Okay, another term we have to be familiar with is multiplicity. Okay, multiplicity, the root word sounds like multiple, sounds a little bit like frequency, and that's exactly what we're talking about here. So this is the number of times a solution repeats itself. Okay, so for example, let's look at two different equations. Okay, equation number 1, f of x equals x squared minus 4x plus 4. Okay, if I was told to find the solutions, I would factor this. And this one will be a pretty easy factor. What adds to negative 4 multiplies to positive 4, x minus 2, x minus 2. Now here's where the multiplicity comes into play. I only have one solution. Even though it looked like I had two roots, I truly only have one. So if I was graphing this, think of a really shortcut way to graph it. If I rewrite this equation as f of x equals x minus 2 quantity squared, I have an equation in vertex form in which my graph shifts 2 units to the right. All right. I already knew I had a parabola. I know the vertex, and I know my zeros. Okay, I digress for 1 second. So I have a multiplicity of 2, because this solution occurs twice at x equals 2. Okay, so don't get too hung up on it. Multiplicity just means the frequency with which that zero occurs. Most of the time it's probably going to be just 1. Okay, second equation. F of x equals x minus 3 and x plus 1. Well, if we were graphing this, something should tell us right off the bat that I have zeros at x equals 3 and x equals negative 1. The other question I would ask myself is this a happy parabola or a sad parabola? Both of my x's, if I were to FOIL this, would give me a positive result when multiplied together. In the past, we've gone into computing the mins and the maxes and, well, the vertex to get a perfect parabola. Right now, for this exercise, we're not going there. So we're talking about multiplicity still. I would say we have a multiplicity of 1 at x equals 3 and x equals negative 1. Now there's a little trick to figuring out how the multiplicity affects your graph. If your multiplicity occurs an even number of times, so here we had 2 positive 2's, you touch on the x-axis and you continue on. If you have an odd multiplicity associated with your answer, you will cross the x-axis. And we'll look at a couple of examples. Okay, number 1. Equation f of x equals x plus 3 quantity squared. This is even, so this will touch. Times the quantity x plus 1 times the quantity x minus 3 to the third. Now this is odd and this is odd. So it will cross. C-R-O-S-S. Okay, now the other thing I need to figure out, what degree is this? So what is my graph going to look like? All right, so there's 3 steps we need to take. Number 1, figure out the end behavior. Number 2, or letter B, what are your zeros? And letter C, what are your multiplicities associated with those zeros? Okay, end behavior. If I was to multiply all of this out, if I FOILed this, I'd have an x squared. If I FOILed this, oh goodness, I would have an x to the 6th power in there somewhere. And then, I should say x to the 3rd power, and then I have another x to the 1st power here. So, first term, second term, third term. I don't want to FOIL all this up. That doesn't sound like fun at all, when all I need to figure out is my degree. So when you're multiplying, remember you add your exponents. There's not a 1 there, but unofficial or officially that there is. 3 plus 3 is going to give you x to the 6th power. If you have a positive x term and an even degree, you will get a graph whose end behavior will be pointing up in both directions. So that gives us 1 hint. Okay, we need to find our zeros next. The first term would tell us x equals negative 3. The second term would tell us x equals negative 1, and the third term would tell us x equals 3. Now the multiplicity here, you have negative 3 2 times, you have negative 1 1 time, you have a positive 3 3 times, and here you're looking at your exponents as it relates to each of those terms. If you have an even multiplicity, here's what I want you to write on your paper, ETOC. Even multiplicity will touch the x-axis. Odd will cross. So when we're approaching and we're sketching our graph, we will actually cross the x-axis at these 2 points, C-R-O-S-S, and we will touch and bounce back when you have an even multiplicity at 2. Okay, so let's try to graph it. Here's our y, here's our x. I know I'm going to have some key values at my zeros. So let's go out 1, 2, 3. Here's negative 3, here's negative 1. And let's go out 1, 2, 3 on the positive x as well. Okay, so I have a graph that looks like this. It is going to touch at negative 3. This one's going to be a touch. It's going to cross at negative 1. It's going to come down, and then at positive 3, it's going to cross again. I know that it starts from the very top and comes down. So we're going to come down. We're going to touch or bounce up a little. We're going to cross here. And I know I need to cross back when I get over here. So my end behavior will look like this. Okay, so here's my x-intercepts. Helps to fill those in first. Figure out what your end behavior is doing. And then start and figure out, do I cross or do I touch? And if you touch, it's more of a bounce when you're graphing. That may help. At this point, we will not worry about exactly what our mins and maxes are. We're just worrying about getting the flow of the graph going in the right direction. Okay, number 2. Let's try f of x equals x plus 1 quantity squared times the quantity x minus 2 times the quantity x minus 3 to the 3rd power. First thing we want to do is figure out our end behavior. Okay, I have with my first term, and x squared. With my second term, an x to the first, and with my third term, an x to the third. Real creative, we're coming up with the exact same graph. Okay, next step, find our zeros. Okay, first zero, x equals -1. Second zero, x equals +2. Third zero, x equals 3. And then letter C, find your multiplicity. P-L-I-C-I-T-Y. Okay, at x equals -1, multiplicity is 2. At x equals +2, multiplicity is 1. At x equals 3, multiplicity is 3. Even, remember, even touches, odd crosses. So at even, we'll have a touch, odd, we'll have a cross. Okay, I'm expecting this graph to look a lot similar to the last one. Let's plot out -1, +2, +3. I guess we could actually plot some points at -1, +2, +3. And then as long as this term's positive, we're going to end in a positive direction for both sides. First term, when x equals -1, we are touching, and for the next two, we will cross. So we're going to come on down. We're going to touch and bounce up, and then we have to cross, and then we have to cross again. Again, I know it's tough to worry about because you want to see or you want to know what those mins and maxes are, but again, that's not what we're doing at this point. All right, last one we're going to try together, and then I'll let you try some homework. Number 3, f of x equals -x plus 1 to the third times x minus 1 times x minus 3 squared. Okay, and behavior. Similar but different. The first term would give you an x to the third. The second term would give you the x to the first. The third term would give you x squared. However, we have a negative hanging out in front. So when you add all those exponents together, you will get end behavior that ends in a downward direction on both sides. Okay. Letter B, find your zeros. Okay, the negative doesn't come into play here. Still looking at what's inside your factor polynomial here. So we'll get -1, we'll get a +1, and we'll get a +3. Multiplicity, last step. Multiplicity is 3, 1, and 2. So we have odd, odd, and even. And then if you remember correctly, odd will cross, and even will touch. Okay. Now when you go to graph this one, there's just one subtle change you're going to have to make. Let's plot our points at our zeros, -1, 1, 3. Now this time, because it's upside down, we're going to come from the bottom. And on -1, we're going to cross. +1, we're going to cross. 3, we're going to touch. So let's come up and cross. Go down and cross. Turn it around again. Come up, touch, go back down. And that's pretty much it. Your homework. Page 269, 7 to 12 all, 15 to 24 all, 43 and 44.